Hello and welcome back to module number 9, and today we're going to talk about multivariate analysis, and we are trying to implement the idea of not a single variable, not a two or three variable, but a multiple variables into the analysis. And one of the best way to do that is to convert it into visualization in order for us to display quite clearly what the analysis show us. So before I will jump into multivariate analysis, and this is really important module for me because here I'm going to introduce to you the one of my favorite R packages called ggplot2, but we will do that gradually, and we will introduce other packages and what they provide. But we will also talk about, I would like to start this conversation about your final project that some of you already asked or requested more information. So now it is open. So the final project in the class is that you need to create your own project, and you're going to share it with the link on Canvas, and you're going to create a blog on it where you're going to describe, and you're going to select the data set you like to analyze. If you have issues, please let me know. I have my own data sets that I will be more than happy to share with you, but I want you to decide for yourself what is of your interest in order for you to apply it or to develop it. In this process of generating your own project, you're going to have some steps. The first steps is you're going to create something that of interest, and I ask that you will have at least 50 observation between 5 to 20 variables, and this is part of the issue. Then you're going to create a short summary. Why is it so important? Because the summary allows you to give you some dimensions of what the project is. So you're going to write a statement, what is the problem you aim to describe and what is the solution that you are trying to solve with your problem. Example, if you are into sports, no one is counting how many mistakes players do in the game. So you're going to collect this data and you're going to visualize it. This is part of the problem that things like that does not exist. And so the issue here, you are going to try to solve a problem. I want you to think higher level than mistakes that players do. But if you choose that type of topic, I highly encourage you to do that. And then you're going to visualize it. But the last part is that you're going to have visual peer review, which is again my obsession in life. Why is that? Because as I told you before, visualization does not have rules as English language does, which means that it's really a little bit free, and we're trying to make it more coherent and more concise. So the visual peer review is my contribution to the field by saying that if other people will see your work and be able to review it, that will be essential to what you are doing and how to do that. So you're going to be judged on 3 rubric, clear and detailed through libraries if you're going to describe it in your project. Life factor, is it a life factor that can be found in your data set or your visualization? Did you use Adobe Illustrator to cover up things that does not exist? This is something that is really important. Is there a lot of what they call junk elements, which mean unnecessary elements that overstated the issue? That will be judged too. And the best practices that can be found based on our textbook. So those are the rubric that we are going to use. So the issue is I gave you examples of people work in the past, and I hope that will give you some indication the importance of this project. Okay, back to our multivariate analysis and much more. Okay, so let me, whoa. Sorry. Too many browsers open, sorry. Okay, here it is. Sorry, my mistake. Your professor is getting old. Okay, so you're going to read chapter number 4, and this is the subject of visualization patterns over time. And I see it over time because time can be also multivariance in itself. And I will start with general graph design, as many of you ask me to do, even though I do that all the time through our textbook. I will do another pair of principles that might give you some idea that how we see visualization and how do we analyze it. What is the grammar of visualization in compared to text? And this is something that is really important to me. So I will highlight 5 principles, and I will show you principles based on some recommendation. And I always try to remind you that good design is very subjective. It is not universal. We do not have grammar rules as we do in text. And so this is very subjective subject, and this is something that, again, something that you can always argue that is a subjective and it does not apply. I reversed the order of the things based on my analysis or my understanding, but the rule number 1 is he talks about alignment. And the idea that how it should be aligned, everything should be aligned and center in order for you to have a sharp description or design, in order for you to make it more consistent and more coherent. And the aligned elements are not in close connection to other elements, help to provide more visual connection between them. So the alignment is one of the most important basic principles in design. It allowed us to create order that does not exist. And so this is, again, something that you need to apply. And so the issue of alignment is in this slide is really important because we have already too many things going on. It's not aligned, but this is the beauty of it. So it's contradiction, what I have tried to say in the principle, but alignment can be giving you the principles of how you sort things. The second issue is the idea of put together individual elements in repetition, and the idea of consistency in the repetition will make things a little bit smoother to the outside viewer who do not take this class or any other design class. So repetition is important, and in this case, as the example beside, is that you see that they used a big circle with small circle, and it repeats itself. And one of the things that we often see in companies that use repetition is that they use the logo in order for them to repeat the message or the selling points. Contrast is another one, is an idea of create when you have two elements are the totally opposite directions. And so it plays out quite well in the page, especially in websites, and it makes much more impact. Example here is black and white. The issue of how they play with color of white and black and how they play with a text in the same sense. This is again a little bit thoughtful, that give the user or the viewers some insight to the ideas that the design tried to accomplish. Proximity is another one, is again helping to organize the data, and it doesn't mean that you're going to put everything in the same space as the other. No, it means that you should be connected somehow, and it is usually applied to. Now, principle no rule number 5 is balanced. Everything has to have a structure. Everything has to be, it can be systematic structure, but it can be also unsystematic. So it's up to you to decide. You are the writer, you are the designer, you have the freedom to do that. And this is a great opportunity. I will feel empowered if they will let me do my things and let me see how the data play out in order for me to do that. The balance, again, the issue of balance is usually quite well formed in web design, and they try to do that quite often. And the issue of balance is something that, again, is very personal and very efficient. In our textbook, one of the things that, if we're reading the textbook correctly, one of the things that we often use to discuss is maintain visual correspondence to the quantity of the data and avoid at all costs 3D. So maintain, some would argue that rule number 4, proximity, and rule number 5, balance, has the same direction as maintaining visual correspondence, and that might be true. The issue of 3D, our textbook says this is bad, even though it might have all the components that I talked about, the idea of balance, the idea of consistency, the ability to show repeat use of design elements such as color throughout. It is still bad according to our textbook, and this is something that you have to think in order for you to apply. Back to our subject. Again, I try to match up into the subject we are going to talk about. And the issue today, we're going to talk about not 1, not 2, not 3 variables, but multiple variables, and how we capture that in visual corresponding. One of the most popular package in R is called MT-Cars. It is list of cars, all cars, with the mileage, with the heat, with all those systems that play part of those cars, and they rank it accordingly. So those variables are essential. Each one of them play important part. So the value of those variables are used to compare different types of car. Example, Mazda versus Fiat versus Honda versus Toyota. And it allowed us to do more efficient. We need to create, to show how cars compare across all variables at once. So the issue is, for the purpose of this analysis, I'm going to use gross horsepower, and I'm going to apply to it in that analysis. So let's start with ggplot2 and why I'm so excited about that. The idea here is that ggplot2 allowed us to add more dimension to our visualization. But it also allowed us to put the type of graph, which is the case of geom underscore box plot, into action. And in order for us to do that, so in the first example, and you will have it in your canvas, you will see how it plays out if you follow the rule or the code of the R into that, and how it play out. So there is the issue of numeric values like 0 and 1, and how we put the type of graph into the case of the idea. We're going to use linear model and its relationship to multivariable analysis. Simple linear regression, if you remember my statistical class, is continuous outcome and one predictor, whereas multivariable linear regression has continuous outcome and idea of categorical variables. So in multiple variable model can be thought as a model which can be find the right path to the right side of the model equation. This type of model is used to compare between independent relationship while adjusting potential conflict or potential corresponding to this. So finally, in a linear regression, this is the code in ggplot2 in order for us to see it in linear regression. So you have a line, you have the distribution of that particular element, and you see the method and what we are trying to do. So the result gives us linear trend, which the area show that is uncertainty in the fit of its 95% confidence interval of where it is tend to be should be lined up. And it's worth noting that it is not a perfect linear fit, because we always look to see if the values of both the low and the end have the tendency to be higher and would help us to predict. Dealing with those issues are beyond the scope of class, but I want you to keep it in mind. And if you remember the statistical class, this is what we talked about. So in multiple variable linear regression refer to the model of data that often delivered from long dimensional studies where the outcome measured for the same individual in multiple points of time. And that's how I see it. So we are trying to use the time as a component in order for us to do that. Back to ggplot2. If you want to see more than one variable, for instance, you want to measure the effect of not just the weight, but also other values such as the volume or the displacement of the car, we can get the sense that the trend by adding those variables to our visualization using colors and sight can help us to see what is the trends going on. So in this case, I'm adding the X, which is Wt, the Y, which is the speed, and I'm going to apply the idea of the outcome. And again, statistically, it gives you sense what's going on with regard to two dimensions, two variables. One is the circle and the other one is this displacement. And you will see how it plays out in that ggplot interface where we have such as a canvas that show us what it is and how it's being displayed in that sense. So what is the effect? Though three variables of miles per gallon is kind of difficult to determine. It's true that cars with high volume or larger points have a lower fuel efficiency, but it also have a higher weight. So those two variables might be redundant, or as the statistical people used to say, confounded as the fuel efficiency. So same is true is the number of circle. The more circle means both higher weight and lower gas mileage of that car performance. Back to our subject and back to multi-variable display. We are going to see three types of visualization. Each one of them has attributes and things that I want you to think about when you decided how to analyze the visualization. So the first one is GliHex, based on visualization, commonly used ability to multiple data, and it has been established. And it comes from ancient Rome or Egyptian times, where they use that type of visualization to display. So how it works, it's based on written system that is complex, but it is straightforward, and it has inventory of signs which divided into three different categories, namely the sign that writes out of the sign itself. The second is the sign that represent one or more, and the three is the signs that denoted either one or two, and that's the idea of it. And so the idea here is the color, the body temperature, the shape of the head, blood type, thickness is the body mass index. All of those are terminology or biology or health science terminology, and how we visualize it in the idea. So position of the legs, blood sugar level, and how it been played. In addition, using faces to represent key dimensional space was created in this division. And so again, we are trying to capture multiple dimensions in visualization in order for us to do that. I'm going a little bit beyond the ggplot2, and I'm going to talk about one of the most popular package also in R. There's a lot of popular packages in R called cograms, which is ability to have the idea of matrix of correlation. So in this case, this is the example, and the package provides us techniques that basically allowed us to apply correlation analysis with regard to not single variable, multiple variables. So basically is a display of patterns of correlation in terms of signs and magnitude using visual correlation and the ordering of things. So we have a library in this package, we have the data, which is another library that has the data set that we apply. Then this is what I'm going to use in this example. And I posted this example in Canvas so you can see it for yourself. The next example is heat map. And heat map is really smart in a way that it can present four variables with the distribution inside of the map and correlation between them. And so this is an example of it. And again, think about that. We do not want to display only two variables or three variables. We want to display multiple variables. And this is a good heat map, is a good representation of this idea. So in this case, I'm using an NBA because I learned that most of my students in the past like the NBA. I'm pulling data from flowingdata.com and allowed me to create something like this. And this is quite cool because we are able to see rescale, we can see the variable, we can see the name of the player and how they score and how we scale the score in that idea. Another package that is often used, and it is an old one, this is before ggplot2, called Lattice. And it is developed by two guys that use the idea of 3D and be able to hide a high function that not actually print or plot anything, which creates a class which is called trials, which can be printed and plotted in a very nice way. So the lattice graphic is very customized, but pair settings has no effect. So it is an add-on, and we can add to that package other components. And again, I give you in Canvas, you will find the example. And so I first install the package, then apply it, and then run it. And again, the syntax is a little bit different. In this case, I apply y plot, and I give the two variables in it, and I will say what is the data equal to and how we apply, and it will give me something like this. And again, this is apply. you can modify it by the following commands. And so you can, example, you type tplot, and again with the same idea, and it will give you something else, as I showed you in my Canvas page. So what is letters? Basically, usually give you a better look. It allows us to extend the powerful ways and ability to modify the result or give annotation to it, and something that is really accessible. The foundation of this package is based on the idea of a formula, which is the idea that it's if the plots take a single vector, the formula can be written as long, and it has a y vector being named as x, and it will apply the idea of x and y, z and y multiplied by y in order for us to generate it. So this is the basic formula of that, and you can generate histogram in that environment, which will look something like that. And again, it's really clear and it's very accessible. It also gives us the idea with wireframe, which is three-dimensional surface. And if we apply the wireframe into that shape, it will give us something like that. And again, this is something beyond the standard way, and usually it's applied for ecological or scientific science. And this is something quite efficient, because we are presenting here 3 dimensions, row, column, and height, in order for us to display it, and it's powerful. I will not say anything more powerful than a good graph that generate or the idea of display that. What about best practices? One of the things that our textbook talk about is the ranking items by similarities, such as popularity, and you organize or unorganize based on the collection, based on organization of that. That allowed us to give some priorities to one item versus other items and sort them out accordingly. And again, this is the type of visualization that is becomes so popular nowadays, that we can see the conversion between multiple data set and how they play out when you sort the data and you show the connection between one tail to another tail to another tail and how it play out. This is a really powerful visualization. Clustering is another way, and this is again the issue of what is it and how much is it. And clustering, the idea when we talk in everyday language, we're talking about multiple items under the same settings, and in this case we can organizing data based on clustering. And so high cluster, lower cluster, and what we do with it and how to apply that. So example, again, the issue of using heat map in a way for us to do that. And this is something that one of the most popular academic paper that was cited, because they use clustering analysis and heat map in order for them to display this type of visualization. And again, with ggplot2, a common request is multiple plots on a single page. So it's aligned with plot panels, but in this case, the ggplot gives you additional element that is not often used. So in R, we can have a grid.arrange, and it make no attempts at aligning the plot panels. Instead, it merely places the object into a rectangular grid, and it allowed us to fit the cell according to the size of the plot elements. And in this case, this is how it plays. In bar graph in ggplot2, again, we have the idea that highlight the necessary points that are relatively proximity with that regard. So in this case, the points in the line graph will show proximity. And again, reference to the graphic laws that we are trying to incorporate into our visualization. Um, Another way to show trends better is based on Cleveland dot plot. And again, this is how to show some connection, so some similarity that when the user or the viewer see it, it will make more sense out of it. And creating box plot, and again, this is the command, this is the adding condition as a color to the box plot, and adding summary like a mean of the plot summary will add some dimension. To learn about clustering, this is the end, a good example and how to test it, and this is it. I hope you enjoy it. I know that I cover quite a lot of ground, but I hope that it will give you more sense of why is it so hard to have a real clear vision or clear visualization of multi-variables into our display. Until next time, have fun and enjoy.